And we're back. So again, like I was saying, sections 9.6 and 9.7 are very similar to section 9.8 and 9.9 because the end goal is still the same. The end goal of section 9.6 and 9.7 was to find the zeros of the function, to find the x-intercept of the graph, right? That's the end goal out of all of this stuff. We spent the whole first half of chapter 9, sections 9.1 and 9.4, graphing. We spent sections 9.6 and 9.7 solving by factoring and solving by square root method. But section 9.6, does everything always factor? No. Section 9.7, can you do all problems by solving by square roots? No, they can't have that B term. So we haven't come up with a way yet that works for every single possible quadratic. We haven't even learned a way yet that works for every single possible quadratic. So that's what we're going to be looking at in sections 9.8 and 9.9. We're going to be finding a way to solve any quadratic. Section 9.8 is called completing the square. Section 9.9 is called the quadratic formula. All right. So like I said here, the methods in the previous examples can be used only for expressions that are perfect squares. However, you can use algebra to rewrite any quadratic as a perfect square. That is called completing the square. If a quadratic expression of the form x squared plus bx cannot model a perfect square, you can do this process of completing the square. Take a look at the box there. Take a look at the box. What we're going to do is we're going to force something into being factorable. We're going to make something be factorable. And how we do that is we create that last number sitting out there on the end so that it has things that are factors that adds to get to the middle number. Right? That's how something gets factorable. You find factors of that last number that add to get to the middle number. So we're just going to make that happen. Now there's a specific process that you have to go through to make that happen. So what do we do here? Let's take a look. Take a look at that middle box. You see how it says x squared plus 6x? What I want to do is I want to put a number in that box in the end that's going to make that factorable. The number that's going to make that happen, the magic number that's going to make that happen is the b term divided in half and then squared. b over 2 squared. b over 2 squared. You're going to hear me say that a lot. b over 2 squared. It's the number in the middle divided by 2. So in this case, 6. I cut that in half. What is it? 3. I square it. I get 9. So my magic number is 9. My magic number is 9. If I add 9 to that x squared plus 6x, what does that factor into? Factors of 9 that add to get to 6 are 3 and 3. That magic number is so magic that it will always turn it into that thing squared. The two numbers will always be the same. So like in this case, it's always going to be x plus 3, x plus 3. So we could write it as x plus 3 squared. Okay? So the magic number is b over 2 squared. We're going to turn it into a perfect square. Because isn't a perfect square something that you could, square root and it's going to come out nice? That's why it's called completing the square. You could also call it completing the perfect square. Because we're going to turn this into a perfect square. That's what we're doing here. That's where it gets its name. So let's just start slowly. Let's start by just identifying what that magic number is yet. We haven't used it for anything yet, but I just want to take it slow. Let's identify what our magic number is. Okay, so I said it was always b over 2 squared. What's my b value in this case? 20. Cut it in half. What do you get? 10. Square 10. What do you get? 100. And that's my magic number. My magic number is 100. Again, I'm going to write it out here so you can see it. You take 20, you divide it by 2, you get 10, you square it, you get 100. That's how we get that number. B cut in half, then squared. Now, what will that factor into? What are the factors of 100 that add to get to 20? 10 and 10. So this factors into, I could write it as x plus 10 times x plus 10, but we're going to write it a little bit differently. We're going to say x plus 10 squared. And that's going to help us a little bit later on. You'll see why here in a second. X plus 10 squared. Hey guys, where did 10 show up before? Wasn't it that b over 2? That will always happen. That will always happen. The number that's right there will always be the number that's right there. Those will always match. It will always factor into x plus or minus, depending whether it's positive or negative, b over 2. Okay, well, what's my magic number here? What's my magic number? 49. Positive 49. Where did we get that? We took my b term. It was negative 14. Do you see the negative? That's going to come up here in a second. We cut it in half. We get negative 7. We square it. What do we get? Positive 49. And that's our magic number. Positive 49. Now, what will that turn into? Factors of 49 that add to get to negative 14. Negative 7, negative 7. Right? So it's x minus 7 squared. Where else did I see the negative 7? Right there. So in essence, do you ever really need to think about the factoring? Do you ever really even need to think about what will it factor into? You shouldn't, because if you constructed it correctly, it will always factor into b over 2. As long as you've made it correctly. And we'll see what the implications are with that in a minute here. What's our magic number here? 1. If I cut 2 in half, what do I get? Oh, what did you do there? Whoa. Stop that. Get out of it. If I cut 2 in half, I get 1. If I square 1, I get 1. Okay, well that means that this is an x plus 1 squared. Factors of 1 that add to get to 2, 1 and 1. Now, this is just identifying what it is. So what does it mean when we have to actually solve? Well, these are the steps, and you see it on the bottom of your front side there. These are the steps to actually solving by completing the square. Now, we're not going to do all these steps today. Steps 1 and 2 actually come tomorrow. But step 1 is collect variable terms to one side and constants to the other. Collect variable terms to one side and constants to the other. I always actually put the variable terms on the left side and the constants to the right. That's the way I'm going to ask you to do that as well. We didn't even do the last example. Wow. Variable terms to the left side, constants to the right. Step 2, as needed, divide both sides by a to make the coefficient of the x squared term 1. That's going to come up tomorrow. We're going to do that tomorrow. Basically, what we are going to see here is that if you quickly flip over to the back, we're going to come back to the front again, but if you quickly flip over to the back, what do you notice about your a term for all of these? It's just x squared. Is there any numbers in front? No. So things get a little trickier when there's a number in front. That's what I mean by that step. We're going to have to do something with the number in front. Step 3, find the magic number. Step 3, find the magic number. Complete the square by adding b over 2 squared to both sides. And I want you to underline both sides of the equation. Both sides, not just one side, but both sides. Whatever you do to one side, you've got to do to the other. Whatever you do to one side, you have to do to the other. Step 4, factor. You shouldn't even need to think about factoring because it will always factor into that x plus or minus b over 2. Last step, or sorry, not last step, 5th step. Take the square root of both sides and then solve. The last couple steps is all just algebra. The last couple steps is all just solving the equation. That's pretty much it. Okay? All right, let's take a look at it. Flip it over on the back, we're on the top left. Example A, x squared plus 16x is equal to negative 15. All right. So first step. My first step says put variables to the left and constants to the right. Are all my variables on the left side? Are all my constants on the right? Negative 15, isn't that on the right? Yeah, constant just means whole numbers. Are all my whole numbers on the right? Yeah. Second step says divide through by A. Is there any number sitting out front? Then we don't even need to worry about that step. Step 3 says complete the square by adding that b over 2 squared. So let's everybody leave room. Let's rewrite that line here, but leave room. And what I like to do is give myself a fill in the blank. Because that's going to remind me, whatever I do to one side, I've got to put that same number on the other side. So look at my left side. What's my magic number on the left side? B over 2 squared. What's my magic number? Well, what's B? What's my B value? 16. Cut it in half. Cut it in half. 8. Square it. 64. 64 is my magic number. And whatever I do to one side, I've got to do to the other. Next step, factor. Okay, well, what will this factor into? Remember, it's always b over 2. Look here. I'm just going to divide that by 2. X plus 8 squared. That will always happen if you've done it correctly. Now, what happens on the other side? What's negative 15? Get that out of here. Negative 15 plus 64, 49. All right, my next step says square the opposite side. So do you notice how I have something squared is equal to 49? Well, if I just square root the opposite side, what do I get? 7. Be careful. If I square root it, what should we always put in front of it? Plus or minus 7. I square root the opposite side, and I always have to put plus or minus. And now this is where it can get a little tricky, because that is actually 2 different answers. At this point, that's when I have to make my 2 equations. I have to say x plus 8 is positive 7, x plus 8 is negative 7. Because there are 2 separate answers to this. It's not just one answer with a plus or minus in front of it. That x plus 8 equals positive 7 or negative 7. So we subtract over the 8. We get x equals negative 1. We subtract over the 8. We get negative 15. Not too bad. I'll just wait till we start doing quadratic form. Now, why do we do this method? Because this method will allow us to solve anything that's not factorable. Right? This method and then the quadratic formula are both methods that you don't need something that's factorable. You can force it into being factorable. Let's do another one. X squared plus 10x is equal to negative 9. X squared plus 10x is equal to negative 9. Okay, first step, variables to the left, constants to the right. Is that done? Yep. I've got my x squared and my x on my left side and my c value on the right side. Next step, divide through by a. Is there any a term to divide through by? No. Third step, find the magic number. X squared plus 10x is equal to negative 9. And again, I'm going to do that same thing where I give myself a fill in the blank. What's my magic number? 25. 10 divided by 2 is 5. Squared is 25. Now remember, you don't even need to think about factoring over here because that's just going to factor into x plus 5 squared. V was 10, cut it in half, 5, x plus 5 squared. Now what does the right side turn into? What's negative 9 plus 25? 16. Which is really convenient because what does it turn into when we square root it? What's square root of 16? No. 4. Plus or minus 4. See, at this point, this is where I go into my two equations. Remember every time we factored, at the end we had to put it into two equations? Same thing. This is the point where we have to put it into two equations. X plus 5 is equal to 4. X plus 5 is equal to negative 4. We subtract over the 5. We subtract over the 5. Negative 1 or negative 9. Questions about that one? Okay, let's keep it going. Let's do C. X squared minus 12x is equal to negative 20. Okay. Are my variable terms on the left side and constants on the right? Step 1, check. Step 2, is there any a value? Nope. Done. Check. Step 3, find the magic number. X squared minus 12x. And I leave a little room here and here. What fills in that blank? 36. A positive 36. I take negative 12, I cut it in half, I get negative 6, square it, positive 36. Now, what does that factor into on the left side then? X minus 6, yeah. X minus 6. Again, what do we do? How do we get that? You take that number and you divide it by 2. Negative 12 divided by 2 is negative 6. On the other side, negative 20 and 36 make 16. I square root that opposite side now. That gives me x minus 6 is equal to, again, plus or minus 4. At that point, that is where I take the two equations. I have x minus 6 is equal to positive 4. X minus 6 is equal to negative 4. I add the 6. I add the 6. Negative 4 plus 6 is positive 2. I got to tell you what, if I'm given the option, I've done completing the square a long time. I feel like I'm pretty good with the process. Honestly, if I don't know if it's factorable or not, I always do completing the square. If I'm asked to solve a problem like this, I always do completing the square. But some of you guys are going to hate it because it takes a little bit longer time. But you know what happens when you're given a problem that's not factorable? You go through all the process to see if it's factorable, and then you're stuck and it's not factorable. What do you do then? Well, then you have to go backtrack. You've done all that work for nothing. You got to go back and complete the square. Let's do another one here. X squared minus 4x is equal to 77. See, this is an example that would not be factorable. There are no factors that, I might be lying on that. I'm thinking that might, oh no, I lied, that is unexpectable. But at any rate, step 1, variables to the left, constants to the right, check. Step 2 is do I have an A value? No, nothing to divide through by. Step 3, find the magic number. So I've got x squared minus 4x plus something here and that same thing here. Again, whatever I do to the left side, I've got to do to the right side as well. What's my magic number? 4. It's positive 4, which means this gets me what on the left side? X minus 2. X minus 2. Divide this number by 2. X minus 2. So again, it's always b over 2. I square root 81, and what do I get?
9.
What's that?
9
Plus or minus 9. And that's when I create my two equations. I say x minus 2 is 9. I say x minus 2 is negative 9. I add the 2 to get 11. I add the 2 to get negative 7. Okay, let's keep going. Let's do another one here. X squared minus 6x is equal to negative 8. All right, step 1, check. Step 2, check. Step 3, excuse me, step 3. Find the magic number. What's my magic number? 9. How did I get that? Remember, negative 6, cut in half, negative 3, squared, positive 9. All right, so that gets me x minus 3 squared is equal to positive 1. Well, what happens when I square root 1? Just 1, plus or minus 1, right? So x minus 3 is equal to plus or minus 1, positive 1 or negative 1. So again, create my two little equations. X minus 3, x minus 3 is negative 1. I add the 3 to get a 4. I add the 3 to get a 2. Questions about that? Let's do one more. Step 1, check. Step 2, check. Okay, let's find the magic number. Whoa, x squared plus 8x. Leave room. What's my magic number? 16. 8 divided by 2, 4 squared, 16. 16. So that gets me an x plus 4 squared is 25. I square root it. I get plus or minus 5. Create my two equations. I subtract the 4. I subtract the 4. my two answers, x equals 1, x equals -9. I'm gonna stop the video, then I gotta hand out the worksheet.